joining into this workshop. Just a few words from our sides, from the sides of the organizers. So I'm very happy to be the co-host together here with my colleagues Pedro and Jürgen. And we are organizing this ANIVE workshop, which stands for Animation in Virtual and Augmented Environments, now for the third time. And usually we organize it together with with our colleague, actually, Franziska Bruckner, but she's fortunately now on maternity leave. So that's why we have a bit of new colleagues here helping us with the organization. So we are really looking forward to an interesting approximately 2 hours or 1.5 hours this morning. And yeah, thanks for joining us this early on a Sunday. I mean, the schedule is not very optimal, but okay, it's like it is. And yeah, we have to cope with it. And just to give you a brief overview of what to expect from this session. So we're having a total of 3 paper presentations and 1 video presentations that the authors sent already before because they could not make it in person. Approximately 15 to 20 minutes maximum presentation time for each of the papers. And then we have also plenty of time for question and answers. And as you probably have already noted, you could either put in your questions here in the Zoom chat. We will try to identify them here, or you could also use the Discord channel of the workshop, which we are also trying to somehow have a look at. But as we're not that many persons, I think we could stick for the first way, putting the questions here in the Zoom chat. Yeah, that's it's more or less from my side. Perhaps also Jürgen and Pedro, you just want to introduce yourself and say some words to our audience.
Okay, I'll start. Hello, thanks for having me as well, Thomas. Nice to see so many people awake already on a Sunday morning. I'll just say a quick hello and contextualize that I am a traditional animator. I'm the outsider in this animated realities context, but I'm very much looking forward to this discussion and to see the projects that we have aligned for you today. I'll pass the quick word to Jürgen. Jürgen, good morning. Thanks, Thomas, for having me once again. Hello, everyone, anyway.
Hello. Thanks, Thomas, for inviting me for joining this 4th event, actually, of Anim VR. I know this workshop since its beginnings, and I'm very curious about the presentations today. Unfortunately, I have to leave in 30 minutes because I thought that this workshop will start at 9 our time zone. So I was expecting to start very, very early on Sunday. But as my schedule is already planned for other activities today, I will leave approximately in 30 minutes or in 1 hour. So enjoy the presentations. Thank you for having me here on this panel.
Thank you, Pedro. Thank you, Jürgen. So much for the very brief introduction. So I think we could get started. So let me briefly introduce to you the first paper, which will be presented by Jeremiah Dufour. I don't know to pronounce it correctly, most likely, but I tried my best. And the title is All AR Board, Seamless AR Marker Integration into Board Games. And Jeremiah, the virtual stage is yours. I think you're still muted.
Yeah, whenever you start sharing a presentation, one of the windows just disappears, the one where you can unmute. So I think I have everything going. The whole time change thing complicated stuff a bit, but you guys did a great job of letting us know when things started. We just didn't read the UTC+1 and thought it was a bit earlier, but that's okay. We're here, we're awake, and I have the honor today of presenting a bit of research from our lab, Playful Interactive Environments. specifically about the use of markers and seamless marker integration into board games. So we're all familiar with the fact that, like in science fiction films, typically they show these cool technological developments and they end up serving as an inspiration and sort of as a benchmark for real technologies years or even decades later. And this Dejarak scene from Star Wars, I think most of you probably seen it, is a very influential example. It shows two players competing in an animated holographic version of chess. And the game even had a cameo, I think, in the recent version of Solo, Star Wars story. But a quick side note, none of those scenes actually show how players are supposed to control the virtual elements. There are some buttons around the surface and such, but they don't seem to be touching them. And this isn't a trivial issue. So it leaves us game and interaction designers with a few interesting challenges. Of course, you can already play games like HoloChess on available mobile devices. And there are even like additional headset and input devices, accessories that make the experience more playable. However, they're still really single user experiences, and for the most part, they're just well-polished demos. Startups such as Tilt5 have been developing tabletop-based approaches, and they employ these light, really affordable headsets that have built-in projectors, and there's a reflective surface that's on the table, and then there's like a wand-based input device, and all of the applications then run directly from the smartphone. But even in 2021, these devices are still not really available, and they're likely to be just a little bit less expensive than business solutions like the HoloLens 2. And even the HoloLens game demos are just that, they're demos. There are a few multiplayer games like Echelon, which is pretty cool. But for anyone who's actually tested a HoloLens before, you know that the visual quality and the tracking are very impressive, but the input and the interaction can sometimes be frustrating. So we were approached to examine these issues by an Austrian company called Rudy Games, and they design and develop what they call combined games, so analog board games that are supported by an app on a smart device. And these games have a clear focus on this real life interaction. It's a co-located playing experience, and the digital app aims to structure but also to enhance the gameplay. And Rudy Games wanted to push the envelope and create an animated dynamic story based game that was not only for multiple players, but also for multiple devices. And I'll touch on that, why that's important a bit later. So we actually were able to get some funding for this project from the Austrian funding agency. And the project was called Interface to Face. And it had a couple of different goals. So we wanted to have a scalable multiplayer experience. So you could play with 2 people or 3 people or 4 people, and theoretically even more than that. We wanted to have an interactive procedural narrative. So each time you played it, it could be a slightly different story, and you got to make decisions as well with an animated 3D scene and characters. We wanted to have a balance between the digital gameplay and face-to-face interaction. And this is really important because otherwise you're just staring at a screen and you're playing a networked game. Yeah? And we wanted, and this was actually Rudy Games' requirement, that had to be playable on current, affordable, or even last generation hardware. Not just on the HoloLens. And they wanted multi-device support and host migration. So the idea was that we could start a game, but if one of the devices, the battery runs out or something like that, that the game is like lost, that we can have a game running on multiple devices. But if one of the devices is lost, so there are 4, and later there are only 3, that it's still playable, that one of the devices takes over the role so that you're playing 2 players on the same device. So that's not a restriction. That's what we were focusing on in the project. Since we needed to support older hardware for a prototype, and frameworks like AR Core and AR Kit, they'd been available at that time. They're fairly new though. We knew we had to use established markers for a 3D game experience. And this also had the benefit of tying the gameplay to the playing board in the center and anchoring the experience for each player. I assume everyone's probably familiar with AR Toolkit. It's been around since around 1999, but it's still pretty common today to make demos and basic applications. However, there have been a number of developments for augmented reality tracking over the past few decades. And if you take a look at what's currently in use, QR codes are actually used quite often. They can code not only information, but they can be used in tracking applications. And frameworks like Vuforia allow pretty much any image to be analyzed, as you see in the right graphic here, and then used as a marker. There are actually a number of board games out there that already use markers in some way to enhance the playing experience. So there's a game called Chronicles of Crime that uses a variety of printed media to put you into the role of a detective to solve a procedural crime. Again, procedural meaning that every time you play the game, the story can be somewhat different. And the game employs very obvious QR codes. You can see them printed on basically every card that's visible here. And these are then scanned with a smartphone for usage. AR games that use frameworks like Vuforia, though, typically use individual markers, such as in the case of a really excellent student game that has not received enough attention called Nerd Herder, which provides a player with a virtual fishing pole through the lens of the smart device, and you're allowed to lure programmers back to their workplaces. So the marker here that's on the left is a printed bulletin board, and it serves as an anchor for you to dangle this hanging donut in front of the nerds and sort of navigate them indirectly through a maze of office cubicles. So we've been using Vuforia for other projects as well, specifically in the educational game Logistify, which focused on building supply chains for various products. So you had to get the correct sequence of starting at the factory, being moved by truck, et cetera, to be able to trigger the actual animations. And then when you would do a flyover with the smart device, then you would see the animated chain. So it worked on that a little bit before, but this particular project was a bit of a challenge because we wanted to have multiple players, multiple devices, and they all had to be visible. And we developed a number of different prototypes. I'm only going to talk about one today. We don't have all that much time. It's called AR Team. And AR Team is basically a mashup of the 80s TV series, The A-Team, the film, The Bank Job, and maybe a little bit of Fast and Furious, but without the incessant car chases. The idea was to have a board game that consists of individual rooms that could be assembled in different configurations. And although the game is turn-based, players can still use their own devices to like search rooms or play story-related mini games, while other players are busy making choices such as board movement, item employment, etc. But to be able to play the board game from all these different angles with low or mid-tier smartphones, a few challenges had to be addressed. First, the markers had to be large enough so that they could be reliably visible at a distance of 50 centimeters or more and from a variety of angles. As you can see in the picture, you're going to be holding the device up from the board with a bit of a distance. The markers needed to be really robust so that they were visible, and that if there was any occlusion, like some type of object on the board, like like dice, that it didn't prevent the tracking entirely. The markers needed to be integrated into the design in a way that players didn't need to constantly hold their smartphones over the board. And this aspect also affected performance and battery life, as the longer that optical tracking is used, the more CPU power you need and the more battery it will consume. So those were our challenges in developing our solution. So our approach involved creating rooms that could be assembled to create different layouts, as you can see here in this slide, having each room feature a single marker. And these markers could then not only be used as anchors for the visualization, so they could see the 3D scene and the 3D characters and the animations, but they could also be used as checkpoints for player movement. And I'm going to show you basically how we designed those. So since we decided to use Vuforia due to its support for a lot of devices, not just the newer ones, but also older ones, we developed markers that featured many angles, because Vuforia requires lots of angles, lots of triangles, and a high degree of asymmetry. So the orientation is very clear, so that the tracking could work reliably. And what makes our approach a bit different is that we effectively hid these markers into the level design and the overall design of the board. So you can see here how our room markers have been integrated into each of our board elements, with the graphic on the right sort of highlighting the individual markers and how we've placed them in the actual scene. So we play tested our prototypes, and we did this both with these tracked playing pieces for players that also had markers on them, and without. That means just using the smartphones to sort of check into the individual rooms. And based on the results, we developed a few guidelines for this type of marker integration into a board game. The first point is that and this is obvious, but you need a very high level of tracking quality. Because you have multiple markers in the scene, because there's distance there's there, because there's an angle. And the biggest thing here in terms of the design, and you can see 5 of the markers at the top of the screen, is the asymmetry. It may not be incredibly obvious at first because you do seem to have a lot of symmetry in the images, but in fact, there's a high degree of asymmetry in each of these. Another thing that we learned is that in terms of the minimum size, 45 millimeters sort of square is the absolute minimum to be reliably tracked by smart devices with the current cameras that we have in them at a distance of roughly 50 centimeters. Another aspect is that if you're trying to integrate them into the scene, that they have to be sort of part of the environmental storytelling. So they are contributing to defining what type of room that is. Is it an office? It is a dining room? Is it the this is a rich person with a expensive car and they've got their skis on their car, that it actually plays a role in helping to define the scene as well. And then finally, and this one is not as obvious in the beginning, but you basically need to make certain that whatever you use as a marker isn't a standing zone for a character, particularly if you're using playing pieces, that they're not putting something on it that's going to inhibit tracking it. So these are typically areas like a table, a pool table, top of a car that players are unlikely to stand on. Okay, AR team has yet to make it beyond the prototype stage. It was just a research project, and there's no question that markerless tracking is going to continue to improve, and it will most likely replace markers in many applications. However, the use of hidden markers can still be a reliable way to replace, to enhance the traditional board game experience and provide tracking for less powerful and more affordable devices. I think I made it just at about, a little bit shorter, about 10, 15 minutes you said that I had. And I'd like to thank you for your attention and open the floor up to questions.
Thank you, Jeremiah, for the nice presentation and really nice presentation of what you did. Are there any questions from the audience so far? Okay, then perhaps let me start with a, let's say, generic question. So do you think that this AR integration for board games, would this also, or could this also lead to something like possibility to play such kind of games if you're not physically at the same location? Is that something that you're looking into, or do you think the trend still is that you sit together like on the table and play the board games together?
It's an interesting question. Rudy Games, again, is this Austrian company that develop sort of these co-located games, and that's actually the focus of our lab is co-located play. But actually, quite quickly, people started playing board games using Zoom, using all of these different communication frameworks, and of course, having the ability to have a networked application means that you could theoretically play this in different locations at the same time. The thing is, and this is not just in terms of the remote application, but in general, is that it needs to really offer added value. So having the board there, the Chronicles of Crime example is probably the best one that because we showed that briefly. It's an entire collection of clues, that you're sort of assembling together, and being able to spatially sort of sort those clues. That's sort of a killer use of the analog elements, and then having this procedural aspect of, okay, the culprit, the person who's guilty, is going to be different every single time, and the sequence of events and the number of events that can happen is going to be much higher due to the digital aspect. But this whole sort of sorting, putting clues on top of each other, that's still a really analog thing. So yes, I think it definitely could be employed in that way. I think the approach that we had, that you try to assemble the board together, is perhaps the wrong approach for the remote application. But it'd be better to have like printed clues, printed sort of interfaces that you can use for different purposes, and then sort of lay them out on your table, and then you're sort of playing together. But this idea of, and the other aspect as well, is like asymmetric gameplay. So having players not necessarily having the exact same abilities or tasks, but having to sort of collaborate together. I think everyone's probably played a game like this before. Stop talking, or everybody explodes. This type of or start talking and everybody explodes. Those type of games that require somebody has a different view than you do, and they have different abilities than you do. That's particularly interesting in a remote type setting, because you can't cheat them.
Okay. In between, one question came up from the audience regarding the marker versus markerless topic. What's your opinion on this? Do you think that it is something markerless will be used exclusively, or do you still need markers, or for which scenarios you would still need markers in the future?
There are two things to consider. I mean, first, like if you use something like the HoloLens or any of these devices, they work well under controlled conditions. So If you have a room that there are like clear walls, you don't have like windows, like in some cubicles where you have sort of walls that are made of glass. There's not a lot of light, like direct sunlight and such. If you have controlled conditions, things like the HoloLens work pretty well. Yeah, if you've got like clear surfaces that you're going to actually serve as an anchor for a virtual, some type of virtual content. But in situations where that's not the case, markers tend to perform a little bit better. So in that non-controlled environment, I think markers definitely have that appeal. The other thing is that again, we still like to have tangible user interfaces in some way. Yeah, and all of these markerless tracking aspects, like the HoloLens, they're using intangible objects, and you can't really touch them. They don't have any haptics. They don't have any resistance. Yeah. But you can have that with markers, because you can print markers on any type of object. We've done some of our more interesting projects with like printing markers on like rugs or carpets on the floor, and so people sort of walk around, or they can sit down and they can play, and that makes sort of anything into a display. And I think that's also a valuable approach, even if it's technologically possible to do it without a marker. Having sort of a situated display, having that integrated into your real environment, I think has a number of benefits.
Great, thank you. So if there's not another question from the audience, I would like to virtually thank you again. So at least some virtual applause for you.
Thanks.
And I'm very happy to move on to the next presentation, which will be done by Houston Rodriguez. And the title is A Pipeline for Facial Animations on Low Budget VR Productions.
Yes, thank you very much. Let me share my screen. Can I share my screen?
Should be working.
Okay, let's try again. Oh, okay.
I had to stop sharing first. I think you can now.
Okay. okay, perfect. Okay, one second, please. Since my Mac is a little bit demanding today. Okay. Let me try again.
Yeah, now it's coming up.
It's working?
Yeah.
Perfect. Thank you.
Okay, thank you very much. So my presentation will be, first of all, thank you very much for the opportunity. I'm so sorry. I'm a little bit nervous because this is one of the few opportunities that I have to talk about, my work and the things I've been doing. And I don't have a lot of experience, but I'm very happy to be here. And so my presentation will be roughly divided into 4 parts. A brief introduction, a background and motivation, because it's important to understand how I came up with this idea, the pipeline itself, and then the components. I would like to talk briefly about the components. I promise I'll be as fast as I can. So facial animations are something extremely complicated to do. It's very time consuming. And of course, there's a lot of other possibilities and technologies and things today that we can apply. But most of those technologies, and they rely on very expensive hardware, so motion capture systems and this type of thing. And this is a huge complication for small companies and independent professionals and indie game companies. And I was always thinking about also my situation, and you will understand why in a few minutes. And that's a huge problem. So I was thinking about, okay, how to solve this problem, how to create high quality animation, or at least accelerate the production of high quality animations with low budget hardware and software, and a combination of different things. And the alternative to very expensive hardware is doing things by hand, which, by the way, is the way we've been doing in the last few years. And again, this is cool, works pretty fine, but it's works better on very stylized productions. When you want something very realistic, this also can be done by hand, but costs a lot of time and requires professionals, people with a lot of expertise, and this is a huge problem. And when we have this demanding for very realistic reactions in animation, it's really hard to do everything by hand. So it's quite common today to find productions and companies using a combination of different approaches. But in this context, related with animation, there's a lot of alternatives. There's a lot of papers and approaches to combine different things and using, for example, machine learning, computer vision to accelerate the production of animations, but also they're trying to create something that do not require a lot of work by hand. And the focus of most of the papers is not on low budget productions. And this is the point of this paper. So I'm trying to present a way to apply a combination of things to create high quality facial animations for VR productions, for real-time applications on low budget productions. So people without money, but people who likes very much high quality stuff. And to understand how I came up with this idea, it's important to understand the context. I'm doing a PhD right now. I'm trying to finish. And at some point, I had this problem with facial animation. So I had a scholarship, 12 months to develop my entire prototype here in Europe. I'm from Brazil, by the way. And it was not enough because in the middle of the thing, something happens with all of us. So the pandemic crisis, I lost access to the lab, I lost access to resources. So I had to be creative in a way to solve the problem of creating animations. And okay, I cannot use actors, I cannot record this thing because I cannot go to places and I cannot talk to people. And how to solve this problem? So I start trying to combine different approaches. And this simulator that I was developing requires some specific scenarios, conflicts. And the idea of the simulator is to create an environment for training people in stressful situations, more specifically, security professionals and law enforcement agents. And those situations, they require reactions from the trainee inside the virtual reality environment. And the characteristics and technical choices and the aesthetic choices that we made kind of forces us to go to a more towards a more realistic character animation and environments. And of course, it was a decision, but at some point we faced this problem. So how to create high quality facial animations, and not only facial animations, other types of animation, but the focus of this work is specifically facial animations. And we came up with this idea of combining different things, because the purpose of this simulator is, okay, we need to cause a reaction. And this reaction is a little bit complicated. There's a lot of papers that talks about this. So VR on a more stylized way, VR with just focus on tasks, and VR with realistic environments. There's many different approaches, many different discussions, and we chose to go towards something more realistic. That's why we had this problem with facial animations. And as part of the solution, I decided to start testing different approaches. So combining low budget software, hardware that I already have, because I didn't have access to high quality hardware and to do this research. Again, I didn't have a lot of money, so that's why I created this. So this is the pipeline itself. I know it's really hard to see this thing, And I'm going to explain this starting with the two main branches. There's two types of data coming from left and right and going to the same rig. And this, starting on the left, we have the iPhone for the facial motion capture. And this iPhone is connected via Wi-Fi or USB. And we capture the parameters of the animation, because the technology behind the iPhone itself is not that a part of this research, but we kind of use this thing to do the things we need to do. So there's the iPhone. There's also a software on the iPhone, of course. It's a small application, and this application already have a rig with a lot of settings, and we capture the animations with this motion capture system. The app transfers this to this rig and transfer the parameters to the computer. And when we got this parameters, we pass this to a motion layer. It's basically, it's very simple. It's the way motion capture usually works. So we transfer animations to the rig. On the other branch, we have a combination of text and audio. We have an algorithm called Montreux Forced Aligner. And this algorithm, I'm going to talk a little bit about this thing. This, by the way, was not developed by me. I just discovered this thing because as part of my master thesis, I worked with natural language processing. So I have a lot of knowledge about this type of thing, text and voice. And yeah, I learned a lot of things on my master's. I just remembered that I saw something like this in the past. So Force Aligner, I had no idea how to use this until last year when I tried to do this the first time. But anyway, this algorithm basically takes a audio, the voice, the audio input, a text, compares to a dictionary using this algorithm called Montreux Forced Aligner, which, by the way, is just a Markov chain algorithm. So it's very fast to evaluate. And then he aligns the blend shapes with the audio and the text. It's something super cool and generates this very accurate lip sync. And there's a lot of advantages, but the main advantage of this is I can use multiple languages. I can record in multiple languages, and I can use the text for multiple languages. There's, as far as I know, more than 20 pre-trained languages on this algorithm. It's a software. And then we have this also this data, and we combine this data on top of the rig in different layers. And we use both animations to mix this animation. So because sometimes when we have the facial animation coming from the motion capture, it's awesome, it's perfect, but sometimes it's not that good. And we have to improve the lip sync. So instead of doing by hand, if we use motion layers, which is something very common in basically every major 3D software these days, we can combine those things. And after this cleaning process, we can export this to the engine. As a way to demonstrate how I manage this thing, there is a rig. The rig needs to be prepared to receive this type of data. And basically every major face rig is capable of doing that. It's not that complicated. So we have blend shapes, around 50, something between 50, 55 blend shapes. I'm not talking about corrective blend shapes, straight blend shapes for the phonemes, and blend shapes also for some emotions, because when we capture this thing with the phone, we can combine the different types of data, and we can have like a lot of things. And we also have on this rig this square shapes, this diamond shapes. They control clusters of vertices. So we can also move a lot of a bunch of vertices at the same time So that's why this rig is super cool to work with the data coming from the iPhone, because on the iPhone we move this sets of vertices and we have this animation. So I just combine both and just a full review of the thing. We have the hardware, and the hardware is the iPhone or iPad capable of that has the true depth camera and capable of doing this type of thing. Okay. Talking about the software, we have, of course, a 3D content creation package. In this case was Maya, because I've been using Maya my entire professional life. And since this was a research, my first intention was, okay, I would like to use Blender, but I don't know very much of Blender. So we try to, in my case, I try to take the complexity out of the table. So since I know very well Maya and how to integrate Maya with external software, a little bit of programming. So in my case, that was the natural choice. And I am also using mocap X. On the paper, I also talk about different types of applications capable of doing the same thing. It's not only this application, but there's a bunch of other applications like FaceCap, for example, works the same way. They use the same technology as the true depth camera from iPhone, and they capture the data, they transfer to a rig. This rig have a bunch of blend shapes. We transfer the parameters and we use inside the software. With small changes, they work pretty much the same. But the choice for using mocap X is for convenience as well. Since I didn't have a lot of time, I decided to use a software that facilitates my life in the sense of connecting Maya and the software itself. Okay, and the technique is the third component. Animation layers, lip sync with the help of Montreal Force Aligner, and also animations made by hand. It was not very common to add animations. In this case, I just use corrections, the two streams of data to kind of combine and correct, but doing things by hand in this case was not a choice. The idea is to use the pipeline to accelerate the whole work and not to work more. And this is mocap X, and here it's very convenient. There's the app, and there is also a way to connect this app to Maya using Wi-Fi, Bluetooth, or using a cable. It's super easy to do that. But if you want, you can also do the facial capture just using the iPhone, and you can transfer the data after you record this thing to the computer and then apply to the rig, which was the way we did, because I noticed that there's a problem of performance when we do this straight from the app to the rig itself. The rig is extremely optimized because, again, it's a real-time application, and I reduce polygons, small textures, and everything we usually do on a production to make this thing more optimized. But that was the choice. And for the last, we have Montreal Force Aligner. It's a open source code. You can go to GitHub and you can use this thing. Montreal Force Aligner is based on Kaudi, which is a speech recognition toolkit. It's also open source, very reliable. And I also created a very simple interface to connect Maya and Montreal Force Aligner, which is a command line utility. So it receives parameters like strings, and it tries to connect these strings and align with the blend shape. So I send data, I receive data. It's super simple. It was not easy to do that because I'm not a developer. So it took me a little bit of time to understand how to connect Maya and Montreal Force Aligner, but it's possible to recreate the same thing using other softwares. So for example, Blender, Cinema 4D, whatever. All those softwares, they allow to run Python scripts in the background. So you can use Python scripts to kind of connect this guy, this software to Montreal Force Aligner. It's just a way to pass parameters. I think that is it. Thank you very much for the opportunity. And if you have questions, I am open.
Thank you very much, Houston, for the really nice and very inspiring presentation. So perhaps let me start with, let's call it non-technical question, but more psychological question. So, I mean, we were working with the question, how realistic scenes have to be in order to be accepted by, for example, law enforcement officers or emergency service personnel. I mean, what's your opinion on this? I mean, I know that we could discuss for hours, but how much realism do you need for the immersion to be usable for the people?
This is an excellent question. And believe me, I thought about this for a long time, and I did a very deep research on this topic specifically because, by the way, my thesis, what I'm delivering on my thesis is a method for creating VR simulators. I created a prototype until a point, but the idea is to present kind of framework or a model to help people to make decisions. And one of the decisions is, this thing is going to be more realistic or non-realistic, more stylized. So there's different possibilities. We can go, either way. But in my case, I was thinking, okay, the cops, most of again, I was thinking about my country more specifically. The country in Brazil, VR is not something very popular yet. And they know very well how guns work, how the training works, and they have like pretty real experiences already. So they know how to deal with situations. And I was thinking, okay, I would like to make a simulator, but I don't want to give the impression that they are inside a game, something very stylized, which is awesome. Performance-wise, but I want to do something more realistic. And there's authors that say, okay, things more realistic, increase the immersion. And other authors say, okay, you don't have to do realistic things if you have a point, if you have a good objective. And I decided to go towards something more realistic because I'm thinking, okay, they don't know VR. I want them to feel inside the environment. I want them to realize that there's differences, of course, but I want this thing to be as real as I can. So I'm trying to reproduce, for example, the way real guns work, the way the characters, they react. I don't have a lot of characters because I plan to do a very simple scenario. Just 3 main scenes for this prototype. But anyway, I was trying to pursue this more realistic thing. So I think realism is something very important in some specific cases because of the reaction. I want to cause reactions, and the reaction of the user is something extremely important on this context, at least to my research. That's what I think.
Okay, thank you very much. Is there any other question from the audience? I mean, one, not really a question, but like a hint or a link to an application live link phase for Unreal. There's in the chat that you could check this out, whether this is related or how this is related to your work. Any other input or question from the audience?
I have a quick question.
Okay, sorry. Now I saw the live link. Yes, the live link is a way to connect iPhone and Unreal. Yes, there's a bunch of apps doing this, but it's really complicated to do this straight from the iPhone to the engine because, again, it's a real-time application. If you were doing live performances, this works pretty well. But if you are doing animations, you very often you have to treat this data, because usually we do this like in shots or takes, and we need to correct things, we need to improve things. So this is a very interesting example of connecting the iPhone data straight to the engine, but this is not very useful for production, real production. Sorry, Jeremiah. Yes, your question. I interrupted you, so it's a.
I think it's already in the chat, but.
Oh, okay, okay.
So let's have a look at this question.
Oh, okay. Eye movement. Yes. This is a very good point, because again, that's why I try to combine the two sources of animation, because it's impossible to achieve perfection doing things by hand. It's really, really hard. I never saw something extremely realistic doing by hand, but I saw very impressive things with motion capture, and motion capture can also track the eyes. This is one of the main advantages. But motion capture is also very good doing lip sync. But in the case of my research, specifically on my research, the idea is to produce a prototype using multiple languages. I would like to work with multiple languages. So I speak English, Portuguese, Spanish, a little bit of Italian, a little bit of French, but I don't speak German. And German, it was one of the cases. And I need different persons to record different performances to try to, this is a little bit tricky. So if I had just the audio and just the text, I can use the lip sync on any language, any type of language. But if I do this, everything from the motion capture, I need probably someone who speaks different languages to perform again and again and again and again. So this is not very practical. So that's why I'm combining two different streams. It's a way to improve the quality of the animation at the end, because most of the animation are coming from the motion capture system. But the lip sync is coming from another stream. Again, this is an ongoing research. Is this better or worse, or I don't know, this thing works for every single scenario? I don't think so. So we need to test more. We need to probably compare with other workflows to kind of have some sort of, okay, this is a good idea, but doesn't work on every single scenario. And I'm aware of this limitation. Actually, there's a lot of limitations. This is just one of them.
Okay, so I think we have time for two more quick questions from the chat. So the first one by Rob. So what's your opinion on the MetaHuman by Unreal recently announced?
Amazing. That thing was fantastic when they released the first MetaHuman, which is just a very complex rig, a very well elaborated rig. I spent like 3-4 hours decomposing the rig and trying to understand how they did things. It's really amazing, but it's nothing but a very high quality rig. And of course, my first concern was, okay, how this thing works performance wise, because it's beautiful to see, but I don't know about the performance, because we are talking about VR, we're talking about games and real-time applications. And I discovered that they do the same tricks that we usually do in games. They use multiple level of details. So the whole character have at least 6 LODs, and they can change this thing depending on the device, depending on the application. So again, it's just a bunch of very old tricks that we usually use on productions. But I think it's amazing in the sense of giving power to people to create things very realistic. And just talk to any kid today. So they are very used to high quality production, high quality games, AAA games. And when you show things like Super Hot, for example, in VR, it's cool, it's very fun, but it's not appealing. So that's the problem. So we have this visual education. We demand more realism, not we in the sense, you know. I also like very old stuff and very stylized things, but for some applications, I think VR have this possibility of moving people towards something more realistic. And I would like to push this limit, because it's a huge limit. There's the hardware limitation. There's the problem that, okay, when I choose to do something very realistic, I need to do PC VR. I cannot use a Quest for doing the things I'm doing, you know. And yeah, again, it's a trade-off. So I choose to do something very realistic. I cannot use something probably mobile, at least not now. Yeah.
Okay, perfect. And one final last question, which I also think is very interesting, regarding body language. I mean, is there a way to or what's your opinion on this? Is there a way to integrate this into the animation? I mean, okay, it's the mimics of the face is one thing, but is there also like a dictionary, let's say, for body languages?
Ooh, okay. I'm not sure in which sense the question is. I would like more information, because
perhaps we can get a bit more details for this question, or you could also turn on your audio and elaborate on it a bit.
Yeah, because body language is something super important in animation, of course. It's kind of one of the bases of animation. But in our case, in my case specifically, on my simulator, the role of the user is just a quick explanation. There is this cop. He have a lot of experience. He's on the force for a long time, and he's going to guide you. He is the person who guides you on this simulation. Okay, and first we start on the police station, and this person goes to talk with this police guy, and he says, okay, go to the training room, to the shooting room, train a little bit. Is a way to force people to use the gun. Okay, this is super important, because we need to take out the elephant of the room, because when people say a gun, they tend to shoot. It's a VR, so there's no consequence, right? But in this case, I would like to kind of guide people to use the gun, to get use of the controllers. It's a kind of tutorial part. And then the second part, they are at the car, they're going to do a round or something, they're talking, and something happens, and they receive a call. It's a domestic disturbance. And they go to this place, and then the third scene starts. They have to take decisions, because there's a couple fighting, and then the man takes the woman as a hostage. And they need to take decisions, and they need to react to the situation. So this is the short version of the simulator. So yeah. And I'm doing that. This is a very interesting information. It's additional information, because my PhD combines VR, biofeedback, and interaction, of course, you know. And there is a little bit of serious games. It's a type of serious games. It's a simulator with serious games. It's something a little bit more complex. And this paper, it's just a tiny, smaller part of the whole complex thing. Okay. Yeah. But body language is something important. Yes.
Yeah. So the background is I'm an American. I live in Germany, and a friend of mine has actually recently published a book for the police academies here in Germany, teaching them English. It's called On Patrol, and he's been getting more contracts with that. And last year we were at the learning conference in Karlsruhe, and we encountered the VR stands, and we're discussing the option of eventually integrating Yeah, VR into some of the trainings. And so the reason I asked about the body language dictionary is, something I've thought about is, I like the question about the eyes, but there's just, especially cross-culturally, when the police are working with a foreign language for them here, English, there are also useful things that I could see being integrated into training, such as like in the US, when a police officer comes to your window. So even like if you speed, for example, you put your hands on the steering wheel. It's a sign to indicate that you're not reaching for a weapon.
Okay.
And so something like that in an animation in the future could be useful, so that there are an understanding that, okay, those from English-speaking countries such as the US or Great Britain may have different body language motions, and I could see that being integrated into an animated version of some type of a training. So that was kind of the background for my question.
Okay, it makes a lot of sense, and I read many papers about the police culture. It's something related with the thing you are talking, because I had to do that. So I need to know very well this police culture. And the things you are talking about it's something interesting. I never thought about this, because my research do not require this level of animation and this type of thing. I just want to cause reaction. To be very honest, the whole purpose of my research is to prove that using biofeedback is a way to improve the evaluation of cops. So I provoke a situation, a realistic situation. They are inside the simulator, and I'm trying to measure vitals. I'm capturing vitals. So because the problem with police training is, which is not a problem, is the nature of the thing. There is always a more experienced cop, and they will evaluate the trainee based on their experience. And there's a name for that. It's called bias. If I like you, even if you do wrong things, I'll try to be nice with you. So I'm trying to solve a lot of problems at the same time. So providing different scenarios, because in Brazil, since we don't have a lot of money, they don't have different scenarios to train different things, different perspectives. The second problem is the bias. And I'm trying to provide a way to give more information. So it's a evaluation based on data. If this guy is very nervous, if this guy tends to react abruptly to a situation, I can measure this kind of thing. I can give, okay, it's not going to eliminate the bias, the human judgment, but I'm going to give some support to evaluate the cops. So in my case, I didn't need this type of animation, but it requires facial animations, reactions. I want to make the victim very expressive. I want to make this type of thing. So the basis of my research is there, just so you understand this whole thing.
Mm-hmm.
But it's a very interesting question, and I would like to think more about this.
And you haven't encountered any work in terms of perhaps linguists or others who've begun creating cultural body language lexicons or something like that?
No, to be honest, I didn't, but probably because I was not looking for that. But this is super interesting, because it's a way, if we are creating something universal that everybody can use, I think we need to think about that, because different cultures, they have different ways to deal with things, and they have different problems as well. So for example, one of the scenarios, I remember that Professor Jeremiah was my local advisor during my PhD here. And we have the first meeting we had, I presented a bunch of scenarios. And he told me, okay, some of the scenarios that you're talking about, they're not realistic here in Europe, because we don't have this type of problem, but we have in Brazil,
right?
You know? And that's something related with culture. This is something we need to think about, because I'm trying to solve problems. Right now, they're kind of generic problems. They fit on every single country, every single police force. But of course, I cannot solve all the problems in all the countries. So this is super pretentious. I don't have this intention at all.
Thanks.
Okay, thanks a lot. Also,
Thank you very
thanks
much
for all the nice questions and discussion. Unfortunately, I think we have to move on a bit in the schedule.
Yes.
I guess there definitely will be plenty of time afterwards to have also discussions either in the Discord channel or via email or any other platform. So thank you again, Houston, for your very nice presentation.
Thank you very much.
Yeah, and looking forward to getting also in touch here in Austria to see if there is any possibility of doing something together. This really might be very interesting also for our side. Thank you very much. So I would like to move on to the third presentation then. This paper is titled Interactive Narrative Facial Expression Animation Generation by Intuitive Curve Drawings. And this paper is by Xiang and Yan Ling. And I guess Yan Ling will present this paper. Is this correct? So Yan Ling, if you're already here, please start sharing your screen. Because I thought I saw you before on the chat, but now you're not here anymore. Is this correct? Okay, let's try to wait for 1 minute if we can get Yan Ling here to present the paper. If not, we make a brief switch of schedule and play the video of the fourth presentation instead. Okay, so okay, good. Then let's do this. Start with so we're talking now about the fourth paper, which is by a set of authors who unfortunately could not make it today because they are like living in a completely different time zone. So it would have been somewhere in between the night for them, which was not too nice. So they provided us with a brief video presentation about their works, and I will share their video with you. The paper is titled Effects of Virtual Instructors Facial Expression in a 3D Game on Japanese Language Learning. And I'm trying to share my screen. So it should be coming up in a second. And I'm starting also the video for you.
Hello everyone, my name is Dishon. I am a PhD student at Purdue University. Today we will be presenting our research. Our title is Effects of Virtual Instructors' Facial Expressions in a 3D Game on Japanese Language Learning. So the current problem that we found in Japanese language learning is that it is unclear whether facial expression, one of the most important elements of interaction, affects in-game language learning motivation or not. So our purpose is to investigate if the facial expression of the other party, in this case the in-game virtual instructors, will influence the language learning process for L2 Japanese students or not. L2 in this case means second language learning. So we're not aiming for native speakers, we're aiming for international speakers. So the background of our research is that currently there is a rise in research about language learning motivation, and there's also a lot of developed Japanese language learning games such as Crystallize, Influence, and some people use already developed famous games like Pokemon to learn Japanese. And these games somehow what includes some sort of facial expressions when you're interacting with the virtual characters. So we found this area to be really valuable to do a research on. For our methodology, we have created a 3D Japanese role-playing game that is called Daigaku Life. We have 4 conditions in this game, that is the facial expressions of our major characters in the game. On the image on the right, you can see we have 4 different facial expressions for all of our major characters. We have angry, happy, neutral, and sad. When you're interacting with them by having conversation and you answer something wrong, they will be showing a facial expression response according to the conditions you're playing on. So in this game, you will be controlling a major character and you will need to complete different tasks by talking to different other characters. So here we have a screenshot indicating that the progress of playing the game. And in this scene, you will be having a conversation with your teacher. If you answer something wrong, you will be shown a facial expression response, like we talked about before, depending on the condition you're playing. And this happens to all the other characters as well. So you need to select the correct form in order to learn the use of polite form and also the casual form in Japanese. For our experiment, we have recruited 84 participants. That includes 4 groups of 21 students. We'll assign them different conditions to play, so this is a between study. Most of our participants are from the 200 to 300 level of Japanese. That means most of them have studied Japanese from 1 to 2 years. There are also participants who have studied Japanese for less than a year, 2 to 3 years, and also more than 3 years. We will also separate them into groups when we're doing the data analyzation based on the years of learning Japanese. Their age is in between 18 to 35. We have 19 male students and 65 female students. All of our data are analyzed through IBM SPSS version 23. So the conditions we have, as we mentioned before, is 4 groups of years of learning Japanese and also 4 different expressions of the facial expressions. The variables we're trying to seek significance on are the variables for language learning motivation. This includes language learning motivation itself, time spent, and also performance. These variables will be recorded based on the questionnaire we created in a scale of 1 to 7. 1 indicating totally disagree, and 7 indicating totally agree. We will be processed based on the data we collected. And as a result, we have found significance on years of learning Japanese on the variable time spent. And according to the Bonferroni test, we found that 1 to 2 year group spends significantly less time than the less than 1 year group, and more time than the more than 3 years group. And we also found, we also did analysis on the gender, that we have done a independent sample t-test. It showed a significant difference in between the male and also the female in terms of language learning motivation. We did not find any other significances in all the other variables. So, as a discussion, we have found 3 major conclusions. First thing is that there are no facial emotion related differences in language learning motivation. This means facial expressions does not affect language learning motivation by all means. This indicates that for software developers and also for game developers, they do not need to focus on one type of facial expressions when they're designing the game. They can just modify and change facial expressions throughout the game depending on the game scenarios or stories. Our second conclusion is that participants who completed the gameplay significantly more quickly have stronger learning motivation than others. This is based on other people's studies' conclusion that people who have completed a task faster, they tend to have more motivation than the others because they're more focused into this task, leading into faster completion. So in this case, students who have studied 1 to 2 years, they have shown more language learning motivation than the others because our content is actually designed more for that level of Japanese learners. Our last conclusion is that female participants were more motivated by the games than the male participants. This is due to the content and the genre of the game, because our game is more like a storytelling based role-playing game. It's more like they're just watching a storytelling video. If this game was more like an action-based, more interactive focused game, this was definitely more attractive to male participants. Plus, we had more female participants than the male participants. So, in the end, we want to talk about our limitations and future work. So for limitations, we had too much in-game elements that distracts from our major purpose. We're also lacking of eye-tracking devices so that we do not know the focus of the participants when they're playing the game. And we also have a vast majority of female, leading into imbalanced data. So for our future work, we definitely want to apply similar research into other areas, into other language learning areas. We want a simplified game with less elements so we can have better variable control. And we also want to enable eye tracking so we can keep track of the focus of our participants. And that leads to the end of the presentation. Thank you guys so much for listening. If you have any questions, please contact me at the email address. Have a wonderful day.
Okay, so that was a brief video. So you might have noticed, since the authors are not here, it doesn't make much sense to put your questions here in the chat now. But if you have any questions, please feel free to get in touch with them either via Discord or for sure also via email. And once again, sorry for that problem that we only could show a video. But yeah, based on the time zone differences, yeah, for some authors it's not that easy to take part in the presentation. So I once again would like to check if the speaker of the third paper is already here. I also tried to contact them via mail because I was in touch with them actually just before the session. So don't know what happened, but I see now in the chat that Yan Ling, you are here. Is that correct? And if yes, yes, you are here. Perfect.
Yeah.
That's nice. So welcome. And I would like to, yeah, please share your screen and start the presentation of your paper. It's called Interactive Narrative Facial Expression Animation Generation using Intuitive Curve Drawings.
Okay, wait a minute. Can you see my screen? Yes. Oh, now I'm going to give my presentation. Our paper's title is Interactive Narrative Facial Expression Animation Generation by Intuitive Curve Drawing. First of all, let me show you the abstract of our paper. This paper presents a type of interactive facial expressions animation generation system based on traditional montage techniques and generative narrative concepts. It could allow users to produce narrative facial expression animation by interactively and intuitively drawing a plot curve based on pre-recorded facial expression animation clips that provide high flexibility and creativity to users with interesting interaction. And here's the content of our presentation. The first is introduction, the second is implementation method, the third is result, and fourth is user feedback, and the last one is conclusion and discussion. Let's go to the first part, introduction. And we all know that faces are one of the primary visual channels we use our faces to convey emotional information, and facial expression may be an intrinsic part of emotional responses and more developed social interactions. This movement convey the emotional state of an individual to observers. Facial expressions are a form of nonverbal communication that could convey social information between humans. The current study shows that the same facial muscular movement is associated with the same emotion in all people through inheritance. So facial expression is a universal communication language of emotion. And some selected images of special facial expression from photos, especially those from famous people, have been widely used in social media as a cultural symbol or social media. Sticker or meme is a very special and high efficient communication symbol. Some users also use facial expression photos of themselves as memes to communicate with others. Animating facial expression could also be a great improvement on meme or sticker. Currently, most of the memes are still images. To make memes or stickers alive, Apple have released an app on iPhone X named Animoji, and allowing users to mirror their expressions to custom animated characters for use on Messages app. Still, it only works with a deep camera on iPhone X. And with the existing facial expression animation technologies work in a monotonous mode and resulting only one animation in the process. It is difficult to generate a narrative facial expression animation, which is usually much more impressive than a tedious facial expression animation. The authors present a kind of interactive facial expression animation generation system based on traditional montage techniques and generative narrative concepts. This system could allow users to produce narrative facial expression animation by interactively drawing a plot curve based on pre-recorded facial expression animation clips, thus provide high flexibility and creativity to users with interest in interaction. Interactive narrative is a form of digital interactive experience in which users can create or influence dramatic storylines through their actions. And interactive narrative their actions can significantly change the direction and outcome of the story. It is a new method of creating rich expression animations to meet users' needs who expect to use animated expression intuitively and playfully. And the second part is implementation method. Firstly, several different facial expression animation clips are prepared, like the figure shows. They can be used to generate facial expression animations. The clips could be recorded or produced by facial expression animation software. And we classified facial expressions clips to be good or bad. The good one will have high scores and bad one will have low score. The clips of, for example, the clip of smiling or laughing will be classified as good and will have a high score. And the clip of weeping or crying or angry will be a bad clip and will have a low score. We have to explain that because we don't have a technical basis for AI development. This study used a Flash environment that the authors team has the technical basis for and support multimedia development. Although Flash has been obsolete, the idea and ingenious method presented in this paper can still be seamlessly integrated into animation based on AI technology. And we can see this table. This table shows a rough score assignment for different kinds of basic facial expressions. Scores may vary from for a certain types of facial expression to a different extent. For example, sad will have low score and happy will have high score. The facial expression animation clip score varies from 0 to 10, and 0 is the lowest score and 10 is the highest score. Each clip lasts about 2 seconds, and to achieve a seamless connection between different clips, the first 0.3 second and the last 0.3 second of each clip are currently processed as neutral expressions. If the system can be combined with AI technology in the future, the transition between two expressions can also be realized directly. And these two figures shows the composition of two different animations based on the same group of prepared clips. We can see that the two clips, two group of clips are the same, but through the different way, we can compose two different animation. It is possible to create various scenarios by interconnecting the clips after user input. If there are 10 clips of different scores and the generated animation also have 10 different clips, then there will be this kind of possible facial expression animation. It's really enough to form a narrative animation. And during the editing process, clips are grouped into libraries, and each clip that forms one animation can only be retrieved from one library. Besides, the system is designed in such a way that each clip can only appear only one time in each facial expression animation. And here is the database of clips will be recorded. And to allow the user to generate facial expression animation using those clips, we created an interactive user interface and allow user input, defining how the animation will be composed. The current version presents the user with 3 input options. First is a random generation option button. It will generate a facial expression animation by randomly associating different clips. And the second is a curve-based input. It will generate a narrative facial expression animation based on a curve drawn by users and refers to the score attribute shows in figure. And finally is a length option, refers to the number of clips that will form the animation. In most cases, the random generation option results in an animation with no logic, while an animation generated based on user input curve will present more logic. The algorithm used in this design is to sample the curve drawn by the users equidistantly and correspond to the extraction of specific segments. And the third part is result. And here is the interface that we created. The system could offer users the possibility to assemble a certain number of clips that will form a narrative facial expression animation. The user interface of the system is presented in this figure. The interface is composed of 4 main windows. The first one is library, the second one is playlist, and the third one is generate, and the fourth one is export and import. The library window refers to a specific folder where the clips are saved here. All clips are grouped into libraries to avoid the clips that do not have any attribute appearing in the same movie. And the second one, playlist window, shows the list of clips that form the generated animation. And we're gonna emphatically introduce this window, generate. This window offers users the generation options. The first option is chart here. It gives the users the possibility to draw a curved line that will based on the score attribute of the clip, and that will define how good or how bad each animation ends. Users could draw a curve intuitively to represent their emotions and get a narrative facial expression animation. By clicking the minimize button at the upper left corner, users can minimize this system interface, and then the user generated expression animation can play on the background interface. And we can see the ordinate. Higher ordinate means better emotion. The curve is drawn manually, which is a more intuitive visual representation of emotion. And the randomize option here can be generate an animation composed of random clips. In most of the case, the generated animation that use this option lack of logic in their scenario. The user also has the possibility limited the number here. They can input number here of clips. It will form an animation by defining the length of the animation. The input export windows here. It gives the users to the possibility to save and open a sequence of clips used to compose an animation. With the save script button, users can save the script of the animation. And this is the Flash Media Player. It is situated in the background of the interface with three options: play, stop, and pause. And you can right click anywhere on the background, it will appear. And here is the final user generation expression animation. Each clip lasts about 2 seconds, and there are 0.3 seconds of neutral expressions at the start and end part of each clip. When the clip starts to play, it first moves from the neutral expression to the current expression and finally returns to the neutral expression. Thus, the transition of the whole video clip is very natural. And the fourth part is user feedback. And we interviewed 15 college students, including 7 males and 8 females. They were recruited for this study to test the system designed by the authors. They were recruited on the condition that they like to use memes or emojis to communicate on social media. And the final feedback is organized as follows. They consider that the system enables a richer expression form of the generated expression animation, and the process of implementation is straightforward. It's quite easy to use. It would be troublesome to use the Animoji feature of the iPhone and other devices to generate abundant animation driven by a person directly. In contrast, this system can provide an interesting and very intuitive way for people to operate. However, they give some suggestions. They think this system can only generate facial expression animations by using present clips. Some users hope it can be used in combination with different animation apps. And the last part is conclusion and discussion. This system is useful for diversify the narrations and that facial expression animation can tell. With some predefined clips, the user can choose to watch and experience various facial expression animations with different ending in between or at the end of the animation. The flexibility of the system is based on the number and the quality of the clips. A higher number of clips will increase the possibility to diversify the story of each animation, and the way the attributes of each shot are assigned will define the efficiency of the system. Currently, the system is designed with Flash. In the future, we plan to make it an app that could work with. Thus, the composed facial expression animation can be very interesting. Dynamic memes or stickers that users could use on message apps. The mechanism described in this paper could also be applied to existing facial expression animation systems, thus allowing narrative design ability in facial expression animation production. In the later stage, the expression library can be enriched through different length expression clips to achieve nonlinear mapping of expression animation and curves, and the AI technology can be integrated so that expressions of different schools can be directly moved to obtain more natural and diverse expression animations. That's all. Thank you.
Thank you very much for the presentation. So is there any, or are there any questions from the audience regarding this talk? If so, please, as usual, put them in the chat. Perhaps let me start with a brief first question. I mean, I'm not an expert in this facial animation thing, but what I could imagine, I mean, does it make a difference for you if you change from like one expression like very happy then to very angry, like from the one extreme to the other? Does this make a difference in changing? I mean, I noticed that you had something that you're always having something like a neutral component in the middle. I mean, what's your experience about this? Perhaps you can tell us a bit about this, like changing from the one extreme expression to the other extreme expression.
We have neutral facial expression at the start and the end part of each clip, so the transition could be very natural. In the future, if the AI technology can be integrated, it will be more natural than now we use the technology.
Okay. Thank you. Is there any other question or input from someone from the audience? Okay. Thank you very much for your presentation. And yeah, then I would like to come to an end regarding the presentation. So thanks once again to all of the 4 speakers and for all of the other people in the audience. And if you're interested, we still have a bit of time for discussion left. So we could discuss the open questions from before if you're interested, or also any other issues related to animation and augmented and/or virtual reality. So I would be happy to discuss any other open questions, but if not, then it's also perfectly fine. And yeah, if you have anything, either just put it in the chat, or yeah, you can just open your audio and share any thought with us. So perhaps to get started a bit, Pedro, perhaps you can tell us a bit. I mean, you are, like you said in the beginning, you come like from the more or less opposite direction. So you're more from a media point of view, I would say. So what's your expression now regarding this let's call it more technical talks? I mean, is this something that you can somehow relate to, or is this something that is not very well related to you? So what's your opinion on this?
Well, like I said at the beginning, yes, indeed, I feel like a bit of an outsider looking into this brave new world, and it was very exciting to hear some of these ideas, especially in terms of expression. I come, as I said, from traditional animation. I do short films. I am fascinated by these worlds, but there was one thing that stuck with me that somehow I would like to go back. It's a question that was left unasked, and answered before, and it was, I think, made by Kao in the chat, and he or she. Sorry, I'm sorry if I'm making a gender mistake here, but basically the question was, I think, put forward towards Houston, although I think it applies to some of the other presenters here. And the question was about animation being suitable for some real work scenarios, such as law enforcement. This person was trying to use animation for delivering criminal cases, but he or she said that people may doubt animation as they are unreal. And I like this question because there's a lot of talk here about being realistic or not. And I come from a perspective that animation doesn't need to be realistic. So I wonder about this. If I don't know if Houston wants to reply to this, but I'm fascinated by this idea that because it's animation, maybe it puts it breaks the flow of communication in a way. And is this a relevant question? And I don't know, I'd like to hear a bit more about this.
Yeah, I would like to answer that. And Pedro, don't feel alone, because I am at the same situation as you. So if sounds that I am a very technical guy, I am sometimes, but I'm not this type of guy. So I'm not computer scientist, I'm an artist. So I am a completely outsider on my program, and I'm doing my PhD on this field because I have a strong passion for animation, for interaction, actually. And VR is just a medium to do this kind of thing, to deliver this kind of thing on a more immersive way. And saying that, it's important to put that, okay, VR is amazing in a lot of different ways, but to me, something super interesting is the possibility of tricking the mind of people, making them literally escape reality, but to a new reality, not to a fantasy place, not to, okay, it's possible, of course it is, but in my case, in the case of my research, I'm trying to do things very realistically. And as soon as I finish my PhD, I hope that next year I'll bring something more close to the things I've been doing on my PhD as a way to show you what I managed to get, because there's a lot of very interesting things. But regarding the question, yeah, it's a problem, because for my animations, most of the animations I'm using motion capture. But since, again, I didn't have access to a motion capture system, I had to use animations from Mixamo, from other libraries. And on top of those animations, I add my own animations. So it's a way to compose animation after animation to create, is something very common on the industry. So we usually do that. Even if they record like big shots using motion capture, they tend to use not that big shots, because motion capture have a lot of problems. Even the big systems, the very expensive systems, always have some jitter, always have some things we need to fix. And that was the case several times. So since I'm using different sources of animation, different libraries, there's always small differences between those sources. So they are body animations, but sometimes they don't work very well together. And that's why, as an animator, I need to go there and I need to fix things and I need to combine things. So there's a lot of manual work. But I always try to keep the animations very close to reality. Okay. And there's also a bunch of other problems. So, for example, discover a way to clean up and reduce the amount of keyframes we have on a animation, because this is a huge problem. As an animator, when we saw a bunch of keyframes, like hundreds of keyframes, we kind of got scared, which is normal. And we try to reduce the amount of keyframes to kind of have a clean curve to work with this a little bit better. But we always use real footage. We always use the original animation as a landmark, as a reference, to try to avoid stylizations, to try to avoid. And this, again, this is my concern. I'm trying to do something very realistic. So that's a concern. But I agree with Pedro, animation doesn't need to be realistic. You can use a lot of techniques to increase some specific features on any type of animation, and you can translate emotions and intentions and this kind of thing. So you don't need to do realistic things, but in my case, in the case of my research, my specific scenario, I was doing things on a very realistic way, and the application of the animations. So everything is not to break the illusion of immersion. That's what I'm looking for on my simulator, but it's a real concern. Again, it's very tricky to get realistic things, but I'm trying.
I would like to expand the conversation now to Daniel. Daniel, do you want to put forward your question that you just wrote on the chat? Otherwise, I'll read it. But I thought it would be interesting. Yeah, go on, please. Thank you.
So for several of these facial animation papers, evaluating the results is kind of difficult because the quality of the animation is very subjective, and whether it looks natural is kind of an opinion. And yet, if you're using this in some kind of professional context, at the end of the day, you really sort of need a qualitative measure of how good some method compares to some other method. So for either of the authors that worked on facial animation papers, what do you think are good ways to evaluate the quality of these results in terms of the naturalness?
Can I start trying to answer that?
Sure.
Okay. This question right now worth like 1 million euros. I don't know how to answer that, to be very honest. As a researcher, I try to stick with the data, but again, there's qualitative evaluation, there's quantitative evaluation, there's different ways to evaluate things. So what is realistic facial animations if you are not using a realistic character like a human? If you are using a cartoon character that have the same features, the same proportions, the cartoon character will be recognized as not realistic. So that's the problem. There's a huge problem here, which is what type of measure, right? So we can, I don't know, we can do a survey and we can try to nail this thing. What is realistic? What is not realistic? This is the first thing. Okay, what is realistic for some people? But realistic depends on a series of things. So I'm trying to reproduce a realistic American character. But if you look to manga, for example, the anime, Japanese anime, I'm going to give a very specific example here. Naruto, for example, he looks very American for me. It doesn't look very Japanese. But people may say, okay, that is a stylization. Yes, every character done by hand will have some sort of stylization. So we think about someone, we don't think about a person, we think about features that define a specific group. So this is a very tricky question, how to measure how real something is, how good something is. There's different ways to do that, but it doesn't matter which methodology we choose to evaluate how good or how high quality something is, or even worse, how realistic something is, because it depends on a lot of variables, cultural variables, the context of the animation itself, and so on. To be very honest, I don't know how to answer. I have some ideas on how to evaluate. Most of them go, towards using data, real data. So for example, we have the face and we have some landmarks, we have some proportions, classic proportions, and we can try to measure how those things works. But again, I'm not a specialist on facial animations. And yeah, there's a specialist in this field. So people who analyze facial expressions and reactions and micro expressions even. So for example, the corner of the mouth. And again, this discussion is not new, it's not easy. So for example, there's a lot of people theorizing even today about the face of Mona Lisa, if she's laughing, if she's not laughing. So there's a lot of discussion about that. It's realistic, it was a person, the features are there, but nobody can define if she is smiling or not. So this is a very tricky thing, but I would like to dedicate a little bit more time, to think about a way to evaluate, because evaluation is, of course, as a scientist, is what we do most of the time. But to be very honest, I don't know how to nail this thing, quality versus how natural is, how good is, because most of the things will rely on human judgment at the end of the day.
Yeah, once again, I find this very exciting and interesting, because relating to the conversation we were having before, that also Riles raised before, the question of behavioral, and how things, like you just said, how things are valued differently in different cultures. Sometimes I wonder if this kind of evaluation does not tend to blend things out too much, because there's the risk of, if we grow this into a worldwide kind of perspective, we tend to blend expressions, and I don't know. I don't know exactly where I'm going with this, but I feel like the richness of all of us here is that we come from different backgrounds and we have different experiences. And so in a way, that's the opposite of what we're trying somehow to do sometimes, which is to communicate on a global scale. And how does that work? Do we lose this identity that we all have in different expressions? And I don't have an answer. This is more like a comment, really. And once again, it works both in virtual world or even in traditional film language. Do we relate more with different kind of cinema languages than others? But this is just a comment. I don't know if anyone wants to expand on this.
No, and I think the problem is, again, it's way beyond animation. It's way beyond virtual reality and so on. So I like opera, theater, and this kind of thing. So I was talking with a friend this week about opera performance. It's a type of performance, but sometimes it's very stylized, because they need to be. They're not actors, they're singers, but they also have to do some interpretation. There's a body language. There's a lot of things going on there. But it's really different when you look to a theater, a theater spectacle. Like when you look to good theater actors, and the difference. So they have a posture, they have a way to speak, they have a way to embody the character, they have a way to even recreate nuances of this character, And this is a very broad discussion. Bringing all those things to animation, we have an additional layer of complexity, because we are trying to recreate reality in computer graphics. Most of the time we try to recreate reality. We have a bunch of limitations, technology limitations, time constraints. We have today, okay, we have great technology, like motion capture is awesome, but there's also limitations. And we try to cope with those limitations. And there's, okay, the cultural limitations. And there's, again, it's a bunch of limitations. But I think the beauty of this type of event is exactly that. So we can hear different perspectives, different backgrounds. It's not looking for answers, but giving ideas on how to try to ask more and more and more questions, because science is about making questions. The answer is a consequence. At some point, we are going to reach something, but making questions and good questions. And I'm leaving this thing with at least a few of them for my research. And I think this is wonderful, But to be honest, I don't know if someone have answers to that. What is good, what is bad, what is beautiful, what is realistic, what is not realistic. So it's impossible to answer that.
And I mean, to let me jump in on this, I think that is also what makes the let's call it the beauty of what we do. I mean, if it would be something like a very strict or evaluatable, I don't know if that's a word, but a discipline, then it would not be that beautiful as it is. Because I think, especially when talking about the theater, I could imagine there is nothing like a ranking of how good an actor is, because either I like the actor or I do not like him or her, but technically they could be the best actors and do everything right and have perfect expressions and body language and so on. But if I have the subjective feeling that I'm not getting warm with this actor, then probably I will not evaluate him or her good. And I mean, that's a good thing, because I think it would be really not a nice world if all of us have the same feelings and expression towards all of the different people and stuff that we are seeing. I mean, that's the subjective of the human nature, and I think that's nice. And I think this also relates very well, or could be brought in very well into the animation area, because even in the animation, I think there are someone likes more cartoons, other guys like more anime style, and there are others do not like animated movies at all. So I think there's a huge bandwidth of interesting stuffs. So I think that's interesting, because in this animation area you need the technical expertise, but yeah, the technical expertise is not all that you need, but it's like an important part. Okay, I would say this, but it's not all of it. So I think that's also why this workshop is so interesting, because it brings really together guys from the more technical area together with guys more from the art scene or arts area. And I think that's an interesting field of work, because you need both of the expertises to really work well together. And I think this was also something like kind of wish for the next year's edition. I mean, just to give you a bit of an overview, what was really overwhelming today, that I just learned that we had over 80 people watching this workshop on a Sunday morning, which in my opinion is really nice. And that's also a good sign for us as the organizers of this thing, that we really came up with something which is interesting for a lot of people in the field. And I think that's also a good sign for us to keep going here, and also broaden perhaps the scope even more, to have such interesting discussions in this field. So yeah, I think this from my side, this was a really interesting Sunday morning, completely different than other Sunday mornings, but still interesting. And yeah, thanks once again to all of you, especially to all of the authors for handing in the papers, and also for the nice discussions today. And yeah, also thanks to Pedro and Jürgen for working together with me here for the co-organization of this stuff. And yeah, I want to say thank you again, and have a nice Sunday, and also for sure a nice remaining conference. I mean, actually the conference is just coming up tomorrow. So yesterday and today is just the day for the workshop. So the real thing will be starting tomorrow and will last until mid of the week. So we're really looking forward to an interesting program. So thank you very much.
Thank you everyone as well. Enjoy the event.
Thank you. Bye-bye.
And good luck with your projects, everyone.
Oh, yeah. Thank you.
Thank you. Bye-bye.
Bye-bye.
Thanks, Riles. I thought you had a last question that was quite relevant in a way.
Yeah. Oh, I'd love to discuss it more.
If we've got time, I don't know, Thomas, do we still have some time?
Sure. I'm sorry, I just closed the chat, so I was not aware of the question. I did not want to.
It was a very good one, by the way.
Yeah, so
a practical application in the daily world. Go on, Riles.
So actually, here in the shop where I am, we have we're setting up my wife is a goldsmith, and and I've been actually going through Code Academy's web development path. So in addition to the English teaching and police work, that's what we've been working on this last year, and Corona is perfect time for that. Anyway, so we do a lot of work here, and So what we're doing right now is in Blender, we're going to be developing a web shop, and then from there we want to set it up. Or my idea is, so my wife watches a lot of YouTube videos where they have kind of an ambiance, so a cafe with cars driving by or that type of thing. And what we have so far in terms of development, we have our 3D printer here. We have I built a light box. We'll do some 3D scans of the jewelry she makes. It's beautiful stuff that she's been doing it for about 15 years. And so we'll take those objects, put them in our shop so the customers can pick them up, look at them. But additionally, there is, how are we going to interact with the customers? Because the reality of the jewelry world is that customers, if they're just looking to buy a piece of jewelry, like a general piece, they'll go to a large store. But when they're looking for something handcrafted, they want interaction. And so part of the consideration is how we're going to do that. Are we going to do that in like a hub? What is that called with Firefox or the anyways, there's these rooms that you can go in, the VR rooms. So that's an idea. But then, these topics, for example, we were talking about it yesterday, spacing between each other. How do you feel comfortable in terms of like how close you are to the customer? And so we're talking about, okay, so if we did a something like in our virtual shop, then we would have kind of like the case with the jewelry, the pieces between us and the customers. And then, but then the thought is, of course, okay, well, if we have a certain time period where customers can come in and interact or something like that, I mean, this is a little bit future-wise. We need to first get some other things on the ground, but thinking about this, like, okay, we use motion tracking in our living room, for example, and then my wife could move and talk to the customers, and just being aware of things like I was talking about earlier with the police work. Culturally, there are different things that are that will play into those, whether or not the customer feels comfortable, whether they feel it somehow, a gut feeling that it's a good thing and they go ahead with a purchase. For them, it's more of an investment into a piece of art, into something that's very personalized, and so they have to feel comfortable in that atmosphere. And so, and a lot of these people are not tech. I joke with my wife sometimes that she's from the 1700s in terms of technology. And so, but that's the world that we work in. And so we really have to be aware of some of these things. So like motion tracking could be a key thing in making, maybe people won't recognize when they put on the VR goggles or looking at it through a computer screen, what makes them somehow feel good. But I think that that's super important because, I think that a Zoom call for the most part, for a lot of people, may not cut it, and so getting these things down is very important. So I thought Houston stuff was great. I get a lot out of the conference just figuring this stuff out and being like, man, this is a lot of new stuff, and yeah, it's pretty interesting.
I don't have much to say. I think I agree. I like those challenges. I think those are really the challenges of the virtual worlds, isn't it? I think this is what fascinates this kind of applications into the practical subjects. Can I say that? I think, but yeah, I'd like to see that virtual shop.
Yeah. Right.
I'd like to see the jewelry, but this probably is for the next year. Maybe you can come back and show that that project for us.
Yeah, I would love to at some point. It's going to take a lot of work, but we'll get there.
Yeah, I can give you something to think about. It's I don't know if you remember, but when the first electronic commerces, e-commerces, they came out, there was a huge problem of trust So people are used to buy things in real world using money, credit card, or so on. So now they have to put the number of credit card on a website to buy stuff. And this problem, okay, it's not that huge today. We have risks, but the risks are mitigated. So people trust more and more and more. And now it's a thing, but took a long time until people, got comfortable with the idea of giving information on a website and buy things.
Yeah.
And I'm thinking about this scenario. Again, it's just to think. I'm not saying this is a bad idea. I think this is awesome to give this experience of buying things in virtual reality. And this type of thing could be even more interesting than buying a car, because because of the amount of money you are going to invest, and you could lose if something happens in the process. But anyway, making a virtual reality with a avatar, with animations, with something more interesting, can make people feel more comfortable with you, of course. So, but this is something we can measure as a scientific perspective. You can measure how people accept a technology. There is a model for measure technology acceptance. There's ways to measure behavior, or at least to analyze behavior of people towards a technology. It's possible to do this type of evaluation. And in your case, I think you should create a prototype and try to test this kind of thing and try to analyze behavior of people towards this thing, how they react, if they are going to buy or not, based on the scenario, the amounts of animations, or the posture, or the the behavior of the seller. And there's a lot of things we can measure and take a decision, think about the decision based on real data.
Yeah, I think yeah, that's right. I was talking to my wife yesterday, and we were talking about how creating a turnover in terms of having customers buy things and not turnover in a negative sense. But yeah, one of the things that we're talking about is probably at the beginning. Our assumption is that what will happen is we'll introduce them to the web shop. Either they can check it out on the computer, or we'll go to live fairs when Corona is kind of a little bit less, and then just introduce them to that. And I think at that point, then they can, I could buy something here. Well, maybe I'll first talk to the person, because like my wife said, they'll probably want to call and set it up and come to us here where we're at in Germany. And so at that point, then they'll know who we are. Maybe they come a distance. But something that's very common in this world, in the goldsmithing and jewelry in this particular world, is repeat customers. So they build a relationship, and then they'll buy from the same place. And so I think part of my thought process is, yeah, it probably will not result in sales directly, at least not on a large scale. It could be that some people are already ready to do that type of thing. But like the other thing of it is, I think that there's worth in creating an atmosphere where, you're saying something through the virtual world, through the setup, what kind of furniture we put in, what kind of, all those type of things, and creating a forum where people could also just go because it's comfortable, and they could enjoy that. And perhaps it would turn into a sale later on, or perhaps they refer a friend who becomes a sale. But it's not just about the sale aspect, but also creating value in other people's lives. So that's yeah, for sure. I hear what you're saying, and just that's a thought process too. Is this eventually having it turn into a sale, perhaps, but them coming here first, or there's a lot of. It's just an interesting field for sure.
Okay, thanks for your inputs, and yeah, we're really looking forward to see the progress of your projects latest next year in the next year's edition. I mean, we don't know where the IEEE VR will be next year so far, but hopefully we could also meet in person there. I mean, let's see how the situation develops, but 1 year is a long time, hopefully long enough. And thanks for all your inputs, and we're looking forward to seeing you all in the next year.
Thank you very much, and enjoy the rest of your Sunday. Thanks for your inputs and projects. Bye.
Thank you.
Bye.
Bye-bye.
Thank you. Yep. Thank you very much, and have a nice day. Thank you.